Hello friends and welcome back to my channel. So today I'm going to be looking at how to evaluate limits of a function in calculus. Now looking at this question, it says evaluate lim x tends to 0, 1 minus e exponent minus x divided by 2 divided by lim x plus 1. So the first thing I need to do here is to test x with 0. So I'm going to replace x here with 0 to see if I'm going to get an indeterminate value. Indeterminate. So if I get an indeterminate value, I'm going to apply what we call the Hopital rule. The Hopital rule to differentiate the expression, both the numerator and the denominator. So doing so, I'm going to write len x tends to 0. So this is going to be 1 minus e exponent minus 0 over 2. Remember, I'm replacing x with 0 divided by len 0 plus 1. This is the first thing to do. So going further, I'm going to have 1 minus e exponent minus 0 over 2 is something as 0. Okay, divided by len 0 plus 1 is 1. So going further, I'm going to have, remember that in indices, anything raised to the power of 0 is 1. So e raised to the power of 0 is 1. So I'm going to replace e raised to the power of 0 here with 1. So that is going to give me 1 minus 1 divided by len 1 is something as 0. So I'm going to have here 1 minus 1 is 0 divided by 0. So this value is indeterminate. I started with 0 and I'm ending with 0. So it means I need to differentiate the expression using the Hopital rule. Okay. Now, doing so, remember that looking at the numerator here is an exponential expression, and the denominator here is a logarithmic expression. So I'm going to differentiate the numerator using this formula. Remember, if you have this d over the x, you have something like this, e raised to the power of ax, where a is the quotient of x, that if you differentiate this, you're going to have is equal to a e raised to the power of a times x. This is the formula. So I'm going to apply this. I'm going to use this to differentiate the numerator. Now, remember that whenever you're differentiating a constant, 1 here is a constant, and if you differentiate a constant, it's going to be 0. So I'm going to have, if I differentiate 1 here, I'm going to have, remember that this is len x tends to 0. So if I differentiate this, I'm going to have 0 minus, if I differentiate this, remember that this expression here, e exponent minus x over 2. So the quotient of x there is minus 1 over 2. So I'm going to apply this formula here, whereby a will be equal to minus 1 over 2. So applying the formula, I'm going to write e here. Remember that this a is equal to minus 1 over 2. That is minus half. So I'm going to have minus half e exponent a, which is minus half again. That is minus x over 2. Okay, that's minus 1 over 2. Minus 1x over 2. That is the meaning. So divided by, so differentiating len x plus 1 is going to be 1 divided by x plus 1. So that is the derivative of len x plus 1. So now in this case, I'm going to test x again with 0. So meaning that I'm going to replace x here with 0. So to see if it's going to give me an indeterminate value. Remember, this is the Hopital. I just applied the Hopital rule. So this is the same thing as 0. This is the same thing as 0 plus. Remember that minus minus is plus. I'm going to write plus here. Half e exponent minus 0 over 2 divided by 1 divided by 0 plus 1. Okay, now what do I need to do again? I'm going to simplify. I'm going to simplify the expression. So I'm going to have 0 plus half e minus 0 over 2 is something as 0 divided by 1 over 0 plus 1 is 1. Okay, and remember that 1 over 1 is 1. So I'm going to have 0 plus half times, remember that this is e raised to the power of 0, and we said that anything raised to the power of 0 in mathematics is 1. So I'm going to times half by 1 divided by 1 over 1 is 1. So going further, this is going to be 0 plus half, which is half, divided by 1, which is half. So the final answer is 1 over 2, or 0.5. So this is how to evaluate this kind of limit of a function. Thank you for watching.